Assalamualaikum. Before we proceed to present our project, I would like to introduce myself and my groupmate. So, begin with myself. Myself is Muhammad Syafiq bin Kamarul Azman, and my student ID is 2019594069, and this is my groupmate.
Assalamualaikum and hi, I am Nur Fareza binti Sahrudin from CS 2486B, 2019-542-569.
Hi, my name is Siti Sarah binti Muhammad Nazir, 2019367403.
I am Umi Kalisa binti Abdul Latif from class CS 2486B. My metric number is 2019725837.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Putri Nusakina. I'm going to present about the introduction simulation of Vaccine Center at Dewan Masyarakat Tawau. Tawau is the capital of Malaysian state of Sabah. We have chosen Dewan Masyarakat Tawau, which are located at Jalan Bakau, Bandar Tawau, Tawau as our study. The services that provided at Dewan Masyarakat Tawau are including consultation and injection to the community. The vaccine center operates every day 9 hours, that's starting from 8 a.m. until 5 p.m. It consists of 25 workers, which is 10 are doctors, 8 are staff, and the others are the volunteer. There are a few counters that the vaccine receipt needs to follow orderly, which are screening counter, waiting room, consultation counter, injection counter, and lastly observation room.
Problem statement. One of the problems faced was the congestion of customers to get or receive vaccines since COVID-19 disease was not well known before. Other than that, the supply of vaccine is limited. Customer who wants to get the vaccine have to wait for an appointment that will be set by the Ministry of Health Malaysia according to the date and time that are available. Next is limitation and scope of the study. For limitation, the accuracy of the project will depend on observation and logic. Represent one vaccine center only, which is Dewan Masyarakat Tawau Sabah. For scope, focus on the main process only, which are screening tests, waiting room, consult process, injection and observation. The whole process will take at least 30 to 40 minutes per customer, which operate only 9 hours in one day. Next, objective. First, to develop a simulation model of the queuing system at the vaccine center of Dewan Masyarakat Tawau in order to have a better understanding of its behavior. Second, to determine the performance of the queuing system in the vaccine center of Dewan Masyarakat Tawau by the output of the SIMAN report from Arena software. Third, to recommend an improvement to the queuing system at the vaccine center of Dewan Masyarakat Tawau.
We had chosen the vaccination center at Dewan Masyarakat Tawau to be the real-world simulation to be imitated by the simulation model. The system was observed only for a day with 9 hours operation, start from 8 a.m. to 5 p.m. The data will be hypothetical data and Arena software will be used to create the simulation model from the beginning of vaccine recipient arrival till the end of the process. This is our data distribution obtained from the input analyzer. Data distribution will be at inter-arrival, screening process and observation process. Meanwhile, consultation process we got Poisson distribution, and the last one, vaccine process, is normal distribution. Next, we can proceed to the basic flowchart of the vaccination process in Arena software. The only modules will be used are create, dispose, process and decide. Meanwhile, for the complete vaccination process, the addition of route and stations modules are being used in the process. And this is the list of our models, station and routes. This is the animation layout for our model. Once the vaccine recipient arrive at the vaccine center, they need to queue at the screening process, scanning the data application and their body temperature. Also, they will get a copy of form that needs to be filled out. They must wait for their turn if there are other vaccine recipients that arrive earlier. Then they must wait in the waiting room for a period of time before their turn is called out to meet a doctor. At the consultation process, there are 4 counters and the process is first come, first serve. The vaccine recipient will be consulted to ensure they are suitable to take the vaccine. If they are in good condition, they will go to the next process, which is vaccine process. In the vaccine process, there are 3 counters and the process is the same as at the consultation process. First come, first serve. Next, they need to undergo the last process, which is the observation process that takes them 50 minutes in the process. This is because they need to be observed by the assigned doctor to look at the after effect of the vaccine. They will leave the vaccine center when the observation process is done. The simulation model must be verified and validated in order to get a good and accurate model. Also, in order to ensure the model is behaving the same way as the real system without any errors. The table shows the steps on how the model is validated by approach 1. In this part, only the main processes will be validated. It shows that all the models are valid since the percentage is less than 10%. By this approach, we can conclude that the models can be used for further analysis. A complete set of experiments is designed to improve the system. For this time, 1 counter at the screening process will be added to see whether the performance at this process is getting better or not. The figure shows the improvement layout of the vaccine center. Based on the output of the Simon report, the average of the total time taken per vaccine recipient at the screening counter is 5.890 minutes, and the average waiting time is 1.3962 minutes. The comparison result will be discussed further in the process analysis by Nur Fareza.
Next, I will explain the analysis and result for our project simulation. So, this is the animation model for the vaccine center at Dewan Masyarakat Tawau. As we can see from the video above, there were 4 processes involved in the model, which are screening process, consultation process, vaccine process, and observation process. As we run the simulation for 6 replication, we get the output, and I will briefly explain the output only for the first replication. As we can see from the televariable table above, the screening tests have the highest average waiting time per entity, which is 14.977 minutes compared to other process. Next, for discrete change variable tables, we can see that the total number of entities who still waiting in the system is 6, where 1 at the vaccine B, 1 at the vaccine C, and the other 4 entities at the observation process. Next, for the output tables, the total number of entities who enter the system is 181 entities, but only 175 of them who have exit the system. Okay, because of the screening process have the highest of average waiting time per entity, we make some improvement on the process by adding 1 counter at the screening process. Therefore, there is a comparison between experimental design and current scenario of vaccine simulation of our project simulation. So as we can see, for experimental design, Table 1 shows the improvement of screening counters utilization time for 3 counters, while for current scenario, Table 2 shows the screening counters utilization time only for 2 counters, and the utilization time for current scenario is both of them above 60%, while for experimental design below 50%. For Table 3, it shows the comparison waiting time per entity between current scenario and experimental design. So as we can see, after we make some improvement on the screening process, the waiting time per entity of screening process is decreased with 1.3962692 minutes.
Okay, now I will talk about conclusion and recommendation. Okay, so for conclusion, the vaccine center at the Dewan Masyarakat Tawau has provided a good service to the vaccine recipient. Secondly, the average time waiting at each counter still in range of the time, which is not more than 5 minutes. Then it conduct the waiting time at the screening process. So for our recommendation is add one more counter at the screening process, and then it will decrease the waiting time during the process. That's all from our team. Thank you.